Hey, this is Corey Glenn, and I'm going to show in this video just the overall technique from A to Z of how to approach one of these really large cases where you need to do extractions, bone reduction, guided implant placement, and then pickup of a prosthesis that's indexed into place. And I'm actually going to show kind of a novel way of picking that prosthesis up, which doesn't depend on pins or anything like that, which a number of people have demonstrated. So when we do this case, one of the prerequisites is that you're going to need to obviously plan your implants, but then you're going to need to do what's called bone segmentation. Now, bone segmentation means that we're going to turn the jawbone into an STL. Now, for the sake of time, I've already done that, and you can see the bone outline right here. This is a tedious process. It's the most tedious process in a case like this, and you would be wise if you want to save some time just to delegate this out. There's a number of good services that you can use. You can use Lab Pronto, which is listed up here. You can use Image 3D Conversion, which is a good company in India. They do it about $50 an arch. Or you can do it yourself. I've got a YouTube video demonstrating an expedited technique, but it's still going to take you probably at least 15 to 20 minutes to do that. So once you have done the bone segmentation, now we're ready to start the process of making these guides. Now, this patient's lower dentition is non-restorable. All the teeth are going to be coming out, and the goal is bone reduction guide, drilling guide, and then a prosthesis. So plan your implants, and as you can see here, we've put in 5 pins. The pins are nice because they do assure that you're not going to have to stabilize this guide in place throughout the whole surgery. Once they're pinned in, it frees your hands up and you're done with that. So the initial thing that we need to do is make the bone reduction guide. Now, this is not a dedicated function within Blue Sky Plan. It's a bit of a hack of the software, but it's relatively easy to do. I do want this bone reduction guide to have the pinholes. So the only guide tubes that I'm turning on currently are going to be the pin guide tubes, which are automatically placed by Blue Sky. When you choose to add a pin, and if you're not familiar with that, you add a pin by just putting plus implant. Here they are. These are the Blue Sky Bio brand of pins, so if you're going to use a different kind, Nobel, whatever, you can just put those in as a custom pin size. So the actual implant guide tubes have been turned off. Oh, no, they haven't. So I need to turn them off. So let's start by unchecking the guide tube here. So I'll uncheck each of these. And again, the goal is simply to have only the pin guide tubes turned on. And one thing you'll notice is that I have in my surfaces panel, after the mandible is segmented, I've turned the transparency down a little bit so that you can actually see into the mandible. I find that useful to be able to visualize what's going on inside of it. And now we're ready to go and generate the guide. So choose the model that you're working on. One thing I would suggest, with these bone-supported guides, you've got really large flaps, and if you're trying to tuck in a 3mm thick guide, which is the standard default thickness, that can be pretty challenging. So it's easy to change that. You can come up here to your guide thickness and reduce that down. 1.5, I find, is pretty good as far as strength versus ability to tuck in. You can go even far lower than that, but now you're going to have to rely not on printing in a in-house plastic 3D printer, but you would probably have to outsource that to someone like Bertram Dental Lab to have it printed in titanium or chrome cobalt. But either one of those works if you do want to get it even thinner. Now, typically, I will also remove undercuts, but in this case, because my bone guide is going to be sitting so close into the jaw, it's going to help me know exactly where to reduce, versus if I remove undercuts and now I have this large gap between the edge of my guide and the bone, it makes it a little more difficult. So in these cases, I do not remove undercuts, but I will also print this mandible and do this as a mock surgery so that before surgery I can go in and hand adjust just enough undercut so that this thing will seat and have a path of draw, but it won't have just a very large path of draw built in. So, done both of those, and now let's draw the curve. I've already done that to expedite this. So if you're familiar with this, you would just draw the curve like you would for any surgical guide. Then you would go to edit the curve, which allows you to now grab each of these nodes and fine-tune your positioning. Where do you position this curve? Well, you want to make sure that you're going apical to your guide tubes, because otherwise you're not going to incorporate a guide. You're going to want to stay up over your mental foramen, because obviously if you pinch that, that's a bad day. And I would go just a little bit below the platform of the implant. And then I try to go from the lingual to about the same height. So as you can see here, by having the transparency turned on, I can see through this mandible and position those at about the same height. Obviously, if you're getting way down here by the genial tubercles, if you're going way up into the mylohyoid undercut, you're going to have problems, so do stay above that. Okay, so now we've got this. Looks like, oops, undo that. Well, I was busy talking and grabbed one of these nodes. So let's pull that back over where it should be. And now we're ready to go. So let's create the surgical guide. So here we have the guide. It's not the prettiest thing in the world, but it's going to serve our purpose as well. You can see that the pins are incorporated in. It has done something a little strange right here. I'm not sure honestly what that is, but it won't ultimately matter, because you'll see this is just sitting right over the teeth and bone, and the goal is that we're going to now create a big window through this and cut that out so that we don't have to rely on this occlusal portion for our bone reduction. So now let's go and start creating the windows. Once again, I will go and turn the transparency down on the guide, because I need to see underneath this where the implants are. I've got the 3D window enlarged completely, and we can use this function here that says cut all, because each cut that we make, we want to make from through the jaw and through this guide simultaneously. It's critical that those be placed in the same position. So I don't try to do all this in one single cut. I'm going to come in here and use the cut all function, and this is going to cut through whatever surfaces you have visible. And now I'm going to encircle where I want the cut to be. And where do I want that cut to be? Usually I want it to be about 2 to 3 millimeters supracrestal from where the implant platform is. So maybe just below the level of this 3 millimeter multi-unit abutment. Here you see the first bone cut, and you get the idea now. This is going to give you the shape of the jaw once it's reduced, and this is now becoming the bone reduction guide. Okay, so now I come back and I look at it from this direction, and I get it roughly in the same plane. I'm going to look at it from this way, and once again cut all, this time coming in from this way, and I'm going to swoop in right there and then come across. And I'm trying to make sure that I don't make things too thin right here. You get that too thin, that can be problematic, and you're back to the point of, if that's too thin, you're going to need to print that in metal as opposed to plastic. I like being able to do things in-house, so I want to try to maintain as much thickness as possible. There we go. Now let's make the final bone cut and guide cut. Again, keeping in the same plane, I will now cut all, and I'll come in from this direction. Excellent. So now we have it. We have a bone reduction guide, which is going to pin into place. As you can see, the pins are in place down here. And so once we lay the flap, obviously do extractions first, lay your flap, and then seat this down over the bone. If you want to keep initially these second molars, or maybe just cut them in half, that gives you an occlusal stop on this portion. Or you could have just cut those teeth out beforehand as if they had been extracted and done this exact same process on just the bone shape of what the jaw would have looked like after extractions. So now we have a bone reduction guide, and I will say I'm somewhat surprised that I didn't get any warnings saying that there was a mesh cut failure. Many times you may get a mesh cut failure, and if that happens, all that means is that there's a little place where the software was unable to completely close the mesh. It's very easy to deal with that. Just export it real quick, take it into Meshmixer, and go to Analysis, and then Auto Repair All, and any little holes in that mesh it will take care of, and you won't have any problems. So now you can see the result. Here is a bone reduction guide, and you're going to be able to seat this over the teeth once everything's been removed, and now you can do your bone reduction. Take the bone down to the level of the edges of this guide, and that will complete your bone reduction. Now we're ready to do the drilling guide. So let's this time turn all the tubes back on. We have now the shape of this jaw, and so I can turn off the reduction guide. I'm also going to turn off all these abutments, just making the screen a little too busy. Let's use the fully guided keyless kit as our method of guided surgery now. And you can see, because of the positioning of where I made my cut, all of these are not going to be impinging, and we can redraw the curve. So let's go back to surgical guide, and let's build it on now this blue model which has been created. Lock the implants in the virtual teeth, normal quality, mandible, and now draw curve. If you get this warning, what it's saying is that you've got a little area where there's an impingement into the model. If that's not a big impingement, I generally ignore this and say that I've got it covered. Okay, so now I'm ready to draw curve. Hold down Shift, draw your outline. There's your edit curve, and now create your surgical guide. Now you can see the surgical guide has been generated, and it shares the same pinholes. So there's a level of verification that this is seating completely, because when you put this in, you're going to know it's not in place if the pins don't go into those same shared holes. So this is your drilling guide, and now we're ready to make the prosthesis. So now you have both of your guides that you needed. They share the same pinholes. We're going to do the bone reduction and then the drilling guide, and then this is going to put your implants in exactly the right position where you're wanting them. And the only thing that we lack now is the conversion prosthesis. So I'm going to turn off the guide now. Once again, you see all the implants, but now what we're really after is that we want to design the prosthesis. So there's a couple of things that we can do here. There's actually many ways that we can approach this, but one of the challenges is that you need to create the space underneath the tissue, or for the tissue. So of course I could just take this model right now, take it into the denture module right here, and build a denture that sits right on this, but now we're going to have to do lots of cleanup and grinding on the bottom side of this. So the goal, for me at least, is to make sure that I leave the space there for the tissue, for the multis, and all that kind of thing. And there's two ways I can suggest to you to do this. One, you could export this, carry it into Meshmixer, highlight this entire surface of the ridge here, and offset that by 2-3 millimeters, whatever tissue depth you want. And now that gives you a surface that is that much higher than this. Save it, pull it back into Blue Sky, and now go to denture module and build your build your denture on that. When you do that, obviously the space that's going to be left, since it's building it on a surface that's sitting up 3 millimeters off the tissue, is going to leave you your tissue height. Another option, I'll just show this one for sake of this demonstration. I could now go into this guide panel, turn all the guides and everything off, and I could build another surgical guide right on the top of this. And what I'm going to do is just go right over the edge of this. The goal here is that I'm going to now create the guide thickness, and I'm going to set that at 3 millimeters because I want to create 3 millimeters of thickness. And this is not actually a guide that will get printed or used. It's purely for the purposes of building a denture on top of to create that tissue space. So here we go. Create the surgical guide. Actually, before I do that, I need to go back and change this. If I want 3 millimeters of tissue space, then I need to make this guide thickness be 3 millimeters. Now, create the surgical guide. And now you see I have a surface that is 3 millimeters thick, and I'm going to actually build my denture on top of this. If you wanted to, you could come in and cut those vertical portions off. So if I just go in here and circle those, we can get rid of them. So now I'm ready to build the denture. Let's switch over now in module and go to the denture module. So now we're ready to build the prosthesis. And obviously this is not a denture, this is a hybrid prosthesis that we're building. But again, it's kind of a hack. We're going to exploit the denture software to be able to do this. I need to turn on the visibility of the upper arch so that I know where to set the occlusion against. I could turn on the implants if needed and see where those are going to emerge. But what I'm going to do now is go ahead and choose the tooth set. And so let's use the Meshmixer flat anatomy. Actually, you know what? Let's go and use the Dave Veage library. This is actually Dave's teeth, and Dave had, like myself, some premolar extractions. So it's a shortened dental arch, which is what I want here. I don't want to have cantilevers. So I'm just going to choose, control selecting these, and I'm just going to go back to first molars, and it's also eliminated a premolar. And then I add these selected teeth as a chain. Shift, drop them in. And here we have Dave Veage's dentition, which we're going to transplant onto this patient. So let's globally align things. Let's pull it over underneath the arch. I could turn the transparency on for the upper arch so that I can see through it to a degree. Now, dialing in the occlusion with the denture module against an existing arch is a little bit of a pain in the butt. It's not a big deal, but it's not currently in this version that I'm demonstrating it in. There's not the ability to cut intersections with the opposing teeth. So what I do is I'm just going to get it close, and if I have, you know, a millimeter or whatever of impingement, I'm not going to worry about that because I'll just adjust that in the mouth. There's enough imprecision in all of this stuff that you can expect to have to dial the occlusion in a little bit, so don't sweat it. The goal here is just a temporary prosthesis, not a dead-on perfect in every regard dentition for the lower. Okay, so let's set the midline. That looks pretty good. That's about the appropriate amount of overjet. We want to minimize overbite, so you can see there's only 1 to 2 millimeters, and now we can line up the occlusion. So if I go to panels and denture design panel, now I can turn on the tooth chain, and the tooth chain means that, you know, the teeth are chained together with 0.1 of space between them. And since I can see through this, now I can begin swinging this dentition like a barn door almost. So I'm going to lock it at the centrals because I like their position. Now if I hold down shift, oops, and I have to do this from the bottom side. So what I'll do is I'm going to turn off the visibility of the jaw and of that, and now look at it from more of this side. Shift, pull that back. Shift, pull that back. And as you can see, it's hinging from the point at which I've locked it. So I like the canine positions now, so I'm going to lock that. I could hinge this one back out a little bit more. Let me undo that. Now I'm going to lock that one and then hinge out the first molar. That looks pretty good. Again, am I after perfection? Definitely not. I'm after approximate occlusion, which I can dial in after I pick all the cylinders and everything up. And now we can begin playing with the vertical positioning of this. So that looks good. The canine needs to come down though. So if I lock both teeth here, I can just pull the canine down, repeat the process here, pull that tooth down. It's easy to see now where the impingement is. And do I care about making that much of an occlusal adjustment? I absolutely do not. And I could even go buccal lingual, dial that in. I think I'll go even more buccal with this. Okay. The molar, that's quite a bit of impingement, so I'm going to reduce that down a good bit. Unlock it. Okay, I don't mind a bit adjusting in occlusion to that degree. That's no problem. Same with here, same with here, same with here. I fully expect enough imprecision in the whole process that, it's almost unheard of to do one of these and then not touch the occlusion. You're going to have to do it, so don't sweat it. Lock both teeth here, pull the canine down slightly. Let's look at the occlusion. That's minimal, so not much adjusting to do there. Now let's lock each of these teeth, pull this tooth down. I like that. Now I'll lock this one and finally dial in this molar. Okay, there is my occlusion. As you can see, a couple little areas where we'll have to do some adjustment in the mouth, and that is perfectly okay. I may bring this canine down just a slight bit more. Shift, pull her down. A little bit more. There we go. So here is our dentition that's going to be the opposing hybrid. And at this point, I don't need the visibility of the maxilla on anymore. There is the tooth setup, and now we're ready to turn back on those other models. And if you remember, we're building the denture on this surface, okay? So now let's build the denture. I'm gonna come up and I'm gonna choose the model I'm building it on, which is the surgical guide. Remember, that's 3 millimeters thick. I tell it it's in the mandible. Let's now create the denture. We're setting a path of insertion. Do I want to allow undercuts? Sure, I don't really care for this purposes. We're going to say next. There's the model that we're building on. And now, how much of an offset? We don't really care about an offset here. That's your spacer off of this model. And because it's going to be, really, we're wanting this to sit up there floating in space, we don't really need that. Tissue thickness, 3 millimeters, that's great. Next. We got to define the closed contour, and so I make this overextended. Again, I would rather have excess material and then dial in the overall contour after we've picked this up, and as long as it's not excessively large, we can grind off flanges pretty easily. Here's our denture base. This is asking, where do you want to build additional gingiva up into? And so I'm going to pretty much set this plane right about the contact point, somewhere right in there. Next. Now I've got to define the contour of where I want to build additional gingiva from. This is a bit of a redundant step, and in the next version of the denture software, we're actually going to eliminate this step because you kind of always do it the same way, so there's not really any need to define it on every single case. And then join back. Next. There we go. So we're pretty far along in the process of having a nice denture. If I was really doing this for a clinical case, I would spend more time to make my occlusion a little bit nicer, but for purposes of this demonstration, this is fine. Now you can use your festooning tools. So if I use the local deform tool, I can, expose more or less of the necks of the teeth. This is a lower dentition, so really how much do you expect them to show? But of course, every patient immediately goes and pulls their lip down and looks at it in a manner that they would never do in real life. So let's at least create a little bit of festooning here. Smooth. If you ever get that little red spot like you just saw there, that's an issue that you need to go back and correct. Now, a word of processing. We've got two ways that we could make this. We could print an individual pink base and then white teeth and then bond those together, but in something like this, I'm after strength, and so monolithic is better in my mind. So what I would probably do is not festoon out the buccal of this at all, but rather kind of leave it like this, because that in essence is a cutback. And now once you've picked everything up, you could within 2 minutes go and apply some pink acrylic in this negative space right here to create the look of gingiva, but have the benefits of monolithic restoration. But if you do want to, dial it in and, create this where it's full contour at exactly the shape it needs to be, you can do that. Just understand you're going to need to go back and print this thing in pink and white. The lingual, I want thickness because I want strength. So I'm going to, oh, that's a little excessive. Okay, that's a little ugly. I'm not worried about it because, again, I will grind that in. For me, it's more about getting this darn close and then me dialing it in chair side as opposed to trying to get it dead on perfect. If you end up spending 3 hours to plan one of these cases, how much are you saving by doing it yourself, really? So I just want to get it really close and then dial it in by hand. That's looking good. Let's go ahead and click next. Teeth offset, that is the spacer between the teeth and the base if you're going to do this as two separate materials. So that's fine. Do I want a tooth reduction coping? No, because I'm not using physical denture teeth, so let's now finalize this. Here is the finalized denture, and you can see it creates these paths of draw for this, but I'm not really after that. What I want is just the solid denture base, so I could turn off the other denture base. This is what I'm after, and all these little R's, those are reduced teeth, and so I could turn off any of the teeth that need to be reduced. Let's now export this, and I'll show you how to create the indexing of the hybrid to the jaw. So export data. And we're going to export the solid base, not the final base. I don't need to export the model that I built it on. I just need the denture base. And this can be a little bit of a pain because now you gotta uncheck all of the teeth that are above here. So right mandibular, second premolar. Let's go up here, right mandibular, second premolar. I don't want to check that. And actually it looks like the newest version, they have done this for me, so that's a huge help. Export it. I'll label this temporary hybrid, save it on my desktop. Let's go to my desktop and now find temporary hybrid. And I'm going to open this in Meshmixer. Open with Meshmixer. There's my temporary hybrid. So, it does have flanges, as we discussed, but the big part that's nice about this is that it's a relatively flat underside. So it will be super easy to turn this into a flat to convex surface. And if I were to import the jaw, so remember that we know what the shape of the jaw is now. I'm going to switch back into surgical guide mode, advanced. And let's turn on the segmented jaw, which we reduced, and turn off that surface. Where is that surface? I want that gone. So check this out. You now have a uniform 3 millimeters of space that your tissue can occupy underneath this. And that impingement will not be there once the extractions are done. Plus, you always need to go back and feather in this so that you don't have a very abrupt change. So after you're done with your implants and everything, go back, feather this in so it's a nice smooth contour to the bone. So final step here, we need to create the indexing method between this. There's a couple of ways that you can do this, but what I'm going to show you initially is, again, variation on the same theme we've been talking about, which is a tiny little bone tray. So let's turn that off. Let's turn all the teeth off. What I'm going to do is come into my guide panel. This time I want this tray to be tiny. I want it like 1 millimeter thick. Yes, let's remove the undercuts. Okay, I'm building it on the blue jaw and normal quality. Lock the implants. I don't need any implants turned on here. Let's draw the curve. Come around. I'm not going to go up onto that area. I'm going to stay clear of it because that's all going to be changed basically. Edit the curve, create the surgical guide. Okay, now I have a 1 millimeter bone tray. I can clean it up a little bit if it built over excessively on this, so you know, maybe even just come in, shift, cut, all of that stuff that's overbuilt. And what I have here is a bone tray. I'm going to export this. I'll call this bone tray, save it on the desktop also. And hopefully you're getting where I'm going. This bone tray is going to be what indexes this prosthesis in space. So whereas some have demonstrated indexing of a prosthesis by stacking, this is not stacking because this is all going to be a one-piece object. Others have demonstrated it by pinning things into place. We're not going to use pins or anything on this prosthesis. Rather, if you remember, I have this prosthesis in Meshmixer, and I'm going to now import that bony tray. Here it is, and now we just need to connect the two. So how do I do that? I'm going to come and I'm going to just select a couple little dots. Now what, you can call these whatever. I call these a sacrificial support. Okay? The idea being that this all remains as a one-piece object until you've done the pickup, and then you can cut this off. So now if I turn this back on, let's push T on your keyboard for transform in Meshmixer and then pull that up. So do you see that that just connected this? This is not an object that you'll be able to mill. This is pretty much something you would have to print in something like NextDent MFH. You could provide reinforcement with Trilor, metal, whatever you wanted to do. But the idea is we have a one-piece object, not dependent on pins, not dependent on stacking. It just indexes itself onto the surface of the bone, which we know the shape of. So now I accept this. I control select both, combine them, and now I have this finished prosthesis. I'm going to export it. And now back to Blue Sky Plan. You can see this is not all that technique sensitive. It's just lots of little steps you kind of got to know the order to. Let's import that STL that we just created, and you can see it all together. Indexing prosthetic. It'll always default up to this to where you can stitch it. We don't need to stitch it. As long as you didn't change its orientation, it will still be in the right orientation. And there you see our prosthesis. The only thing that we are missing at this point is the pickup holes. And it's very simple to make those by just simply looking at your implant emergence positions and then just grinding the holes in. But if you want to be a little fancier than that, you can create specific pickup holes. So here's what I'm going to do. I'm going to right click on each of these implants. So right click that implant, replace abutment. And I find a 5mm pickup hole tends to be the ideal size. So I go to custom abutment. I make the length be just real long, 20mm, but the diameter is going to be 5. And this is going to be the object which we subtract out of this temporary that creates our pickup holes. Replace abutment. Okay, now we've put custom abutments on all of these, and you can see exactly where my screw emergence holes are going to be. So how do I go from this object, which we have now, to one that has these pickup holes in it? Well, the answer is that I will just export all those abutments, import them into Meshmixer, and once again, the easy way, if you just want to eyeball this, just grind through in that hole, okay? But if you're trying to be more precise, let's go now and export the data. And let's export all of those 6 abutments. That's all I want to export. I don't want to export any models, nothing else, no teeth, just these abutments. And back to Meshmixer. Import those abutments. There they are. And now you would just perform a Boolean subtraction of each of these abutments from this object. Now I do find typically if you try to do them all 6 at once, it might crash, it might not, but just to be safe, let's now go in and separate these into their own individual abutments. So I select it. I could have exported them each individually, and that would create 6 different objects, but I'm just doing it now that I've got them all together in here. Edit, separate, select. There we go. 6 individual abutments now, and let's perform a Boolean subtraction. Temp hybrid, control select this abutment, and now let's Boolean difference. There you see the Boolean subtraction. And now this is a bit of a pain, but most often you're going to need to uncheck this box that says auto reduce result, because if I was to click accept, it'll kind of cave this in a little bit. So undo that and just wait for it to do it. Now you just repeat this process 6 more times, okay? Here's the end result. I'm not going to do them all because this is just a demonstration video, but the idea is, okay, you've done bone reduction. You used your guide that pinned into place for that. Bone reduction's completed. Now you put on your drilling guide. So your implants end up in exactly this position, and you knew the shape of the jaw that was going to result from this. And now for your indexing prosthesis, again, not relying on pins, not relying on stacking, you have something that is a one-piece object printed, sitting on the reduced jaw, and now your pickup holes are going to already be present. So in theory, if you did your surgery accurately, you'll take this prosthesis, drop it right over the top, and this bone tray is going to force it into the right vertical dimension and horizontal and lateral position. And so you're going to be exactly where you need to be, complete your pickups, not really worrying about, occlusion and all that kind of stuff. And once your pickup is complete, now come in, cut these 4 sacrificial supports, smooth off flanges. If you want to salt and pepper a little bit more acrylic to make it slightly more ovate, go for it, but your prosthesis is already indexed into place. And when you close this patient into occlusion, the only occlusion adjustments you're going to have to do are those tiny little points where your denture was impinging into the opposing arch, which is nothing. Very easy to do. So rather than me sitting here and demonstrating all that, let me show you an actual clinical case. And so here you see a similar case, this time on a maxilla. We've done just a couple of pinholes. We know the shape of the now reduced bone. You make your bone tray 1 millimeter thick. You can do your Boolean subtractions in this stage or once it's all combined. This was the other method that I was mentioning. I could have opened that reduced jaw in Meshmixer, offset that surface by 3 millimeters if I want a 3 millimeter tissue space, and now build the denture on this. Denture software, set up, build this, but it's floating in space now. And so you would now do more Boolean subtractions through your temporary prosthesis. There's your holes. And now you've got the two objects, the indexing tray and the prosthesis, and you simply connect those two together. You could do those with custom implants, with transform tool, anything that you want. Print this. Again, this is not an object that you'll be able to simply mill out. You'll have to print this. And this is the idea, though, is that obviously it's in an unpolished state here, but when you put this on with your multis and your temp cylinders, they're going to emerge right through the center of those holes, and you do your pickup, and then you cut the sacrificial supports off. Here's another case still. This was a clinical case. You see on the top that's just a conventional 3D printed denture, but the bottom was going to be a hybrid. And as you see, there's sacrificial supports right here. The bone tray puts it into the right position vertically. You can see how nicely positioned in occlusion that it is. And then once you do your pickup, your cylinders are emerging through this, squirt some acrylic, lock them together, and then you'll simply take this out of the mouth, cut the sacrificial supports, leaving you a mostly finished underside to that restoration. Hopefully you see there's many different ways that you can approach these cases. And yes, they're somewhat complex, but it's not crazy complex. It's very doable for the average person once you've mastered the Blue Sky software and a little bit of Meshmixer, and eventually these will all be things that Blue Sky plan you won't have to leave the program to do. They'll just be dedicated functions. But I hope you find this useful and would love to see some clinical cases of it.